So we are kicking off the year with CO1, identifying whole numbers, integers, and rational numbers. So if you remember from the binder last year, there's all these little symbols, right? Here we have the wise old owl. What's the wise old owl? When you see that wise old owl, what does that mean? Remember from last year? Vocabulary words, definition, right? These can go on a help sheet, and we'll talk more about what can and can't go on a help sheet as we get closer to the test. But wise old owls can go on a help sheet. And what this whole objective is about is that it turns out that our number system is broken down into different categories. Some of you that, I don't know, in life science, if you've talked about this before, but you've got like species and then phenoms, right? Is that a thing? Like genomes? Okay, we're live here. Don't make me look like an idiot. But do you know how like animals and plants are like divided into different categories? You know what I'm talking about?
Oh, yeah.
Oh, thank goodness. Whew, okay, right. Well, okay, sports, right? You have the NFL, right? That's the league. Then you have the NFC and the AFC. Those are the conferences. Then you've got the divisions, right? So it gets more specific as we break it down. Our number system is very similar. And the most specific, here's kind of a diagram of it here, okay? With the whole numbers, the integers, and the rationals, and then the irrational numbers are completely separate. But when we talk about whole numbers, anyone know the definition of a whole number? Okay, a whole number is a positive, non-decimal. A positive non-decimal. And of course, just like last year, as Mrs. Gambino wrote down the notes and did the examples, you are doing the same thing in your binder. Okay? So what's an example of a whole number? 10 is a whole number. We'll put examples in red here. We'll be spirit of Christmas. Okay? 10 is a whole number. What's another example of a whole number? Positive, non-decimal.
100.
100 is a whole number. One more just for funsies.
1,000.
1,000 is a whole number, right? Good job. Okay? And as it turns out, this is our most specific set. Okay? Whole numbers are, you could argue, we'll talk about this more later, but the smallest set, the most specific, those positive, non-decimal numbers. An integer, which you can abbreviate with the letter I. Who knows what an integer is? It's the next level up. This would be like the divisions of football. Integers are kind of like the conferences. They include all the divisions, you know. Yeah?
Maybe like a positive decimal?
Okay, not quite. An integer is a positive or negative non-decimal. So what whole numbers and integers have in common is they're both non-decimals. Okay? The difference is integers can include negative numbers as well. So a number like 10, which is a whole number, is it also an integer? Yes. Right? So this could be down in this set also. 100, which is whole, is also an integer. That could be down in this set as well. 1,000, which is whole, is also an integer. That could be in this set as well. But what's a number that is an integer but would not be considered whole?
Negative 54.
Negative 54. Okay? The reason why is because it's negative. Whole numbers are only positive non-decimals. Integers could also be negative. What's another example of an integer only?
0.2? Oh wait. Oh, negative 3.
Negative 3, okay, would be an integer only. Right? What's an example of a number that is both whole and an integer? Both whole and an integer. 2. Okay? It's whole because it's positive. It's an integer because they can also be positive. Right? You see the difference there? Have I lost anyone so far? Okay. Rational numbers, that's the big set. There's 2 lines for the definition because rational numbers can be lots of things. A rational number is any positive or negative fraction non-decimal or decimal that ends or repeats. Yowza. A rational number is any positive or negative fraction, non-decimal, or decimal that ends or repeats. That's a lot. Forgot what a lot of these buzzers do.
Jack the bottom up.
Hmm.
Black one.
The black one? I don't know, I'm kind of afraid to push it. Ooh, it wanted to show me. So, which category does 10 fall under here? Is 10 rational?
Yeah.
Yes. Why?
It's a positive number.
Because it's a positive non-decimal. That's what makes 10 rational. It fits one of these things here. 100, also positive non-decimal. 1,000, positive non-decimal. In fact, any whole number will also be rational. That's why in this diagram here, the holes are kind of inside the rational rectangle there. The rational one's the largest set. Inside of that is our integers, because every integer is also rational. Because negative 54 is a negative non-decimal. It fits that piece of it. Negative 3 is a negative non-decimal as well. So every integer is rational. Every whole number is rational. Where these differ is because it also includes fractions and decimals. So a number like 3.7 is rational because it's a decimal. Is it an integer? No, because integers are only non-decimals. Is it whole? No, because wholes are only non-decimals as well. Okay? So as you work down through this set, every whole number is also an integer. Every integer is also rational, but it doesn't necessarily work the other way. That's because rational is the biggest set here, right? If we put 3.7 in here, it's rational only, not an integer, not whole. We can put negative 54 right here because it's an integer. It's not whole, but it's also rational. Okay? Fraction. Say something like negative 4/11. Okay? Rational because it's that fraction piece. How about this last section here? Decimal that ends or repeats. Who knows what the symbol is to show that a decimal repeats? Yeah.
I like the line on top.
Ooh, I could use it. Hold on. Job well done. Okay. So say we have something like 4.12121212121212, right? And it repeats. The shortcut is to put that little bar over the 1 and the 2, and that's mathematically telling you that that 1, 2 repeats for every number. Okay? Because that decimal repeats, it's considered rational. So, what do we call a decimal that does not repeat? Or does not end? Like pi. Pi goes on forever, right? They've had they've had computers working on this. They have it out to 2 billion plus digits, and there's no end, and there's no repetition. What do we call a number like that? It goes on for infinity, okay? A number like that would be irrational. A decimal that doesn't end or repeat. Okay? An example of that would be something like pi. Okay? Or if it's not a special number like pi is, maybe it's just something like, 10.17389 forever ever. What we would put is we would put the dot, dot, dot. If you see a decimal with a dot, dot, dot at the end of it, can't fit my last, there it is. That means it goes on forever, does not repeat. So you've got all these numbers that are rational. Within that set, more specific are the integers. Within that set, more specifically, are the wholes. And then completely different, separate completely, that's why it's a separate box over here, you have the irrational numbers. Questions, comments, concerns, complaints, compliments, congratulations, criticisms so far? Very well. Okay. Another way to think about this, if this whole box picturesque thing doesn't quite work for you, you are a 7th grade student, right? That's kind of like your most specific role in this school. You're like the whole numbers, okay? You're part of the middle school, which includes the 8th graders, right? When we talk about middle school, we talk about 7th and 8th graders together, but the 8th graders are not 7th graders, okay? You're more specific. And the middle school is a part of St. Vincent de Paul. They're like the rationals, right? That's the biggest set. You can be a 7th grader, be a part of the middle school, and be a part of St. Vincent. But a student in St. Vincent might not necessarily be a part of the middle school or a part of the 7th grade. Okay? That's another way to think about how this whole number system works. So, your job says classify each number as a whole number, integer, rational, or irrational, and then list all applicable categories. 65. Give me a category that 65 falls under. Yes. It is a whole number. Why?
Because it's a positive and it's not a decimal.
Right. It's positive and it's not a decimal. Any other categories that it fits under? Connor.
Integer?
It's an integer. Right? Because every whole number will also be an integer. So every time you write W for whole, you should also be writing I for integer. What other number system is it a part of? Melanie?
Rational.
Rationals. Because every whole number, also an integer, also rational. Number like negative 12.7 though. What category does that fall under? Connor?
Rational?
Rational. Why?
Because it's a decimal.
It's a decimal that ends, right? Negative 12.7. So rational only. Why is it not an integer?
Because it's a decimal.
Because it is a decimal, okay? And the same reason why it's not whole. It's actually got 2 strikes against it for not being whole. A, it's not positive, and B, it's not a decimal, right? Negative 1.
Integer?
Integer. Any others?
Rational.
Rational. Okay? It's an integer because it's a negative non-decimal. And it's rational because it's a negative non-decimal. Any integer will also be rational. Who remembers what this bar above the 7-8 means? Yeah?
Means it goes on forever.
Goes on forever. 2.78, 78, 78, 78, 78, 78 forever. Which means what category is it under?
Rational.
Rational. Okay? Because it does repeat. Rationals can be decimals that do repeat. Irrational decimals do not repeat. Okay, so this is rational. Negative 30/15. It's a fraction, so automatically you know that it belongs to the which set?
Rational?
The rational set, because all fractions do. Any others though? And this one might be a little bit tricky. Sawyer, why? You're absolutely right. Okay, Jimena.
It's not a decimal.
It's not a decimal, although it could be written as a decimal. A little more than that though. We're on the right track, Callie.
It's a negative fraction.
Okay, but integers they can't be decimals. With fractions and decimals, they're pretty much the same thing. It's written differently. But why is this one an integer, Connor?
Because 15 can go to 30 twice.
Exactly. Negative 30 divided by 15, which remember a fraction is really just division. If you were to simplify this, this would equal negative 2. Because 30 divided by 15 is 2, right? And because it equals negative 2 is not a decimal, therefore it's also an integer. It's not whole, it's not positive. But with fractions, you always have to be thinking, can I divide that? Can I simplify that? And break it down, does it work out evenly? If it does, in this case, then you have more categories. 3.360928 ... Amanda,
Rational.
not rational.
Oh,
Why is it
wait,
not?
It's irrational because it doesn't end fully.
Right. That ... tells us it goes on forever and ever and ever and ever and ever. Therefore, it is irrational. Now write this word out just so you don't confuse it with integer and rational together or something like that. Irrational goes on forever. Okay. The irrational, going back to my kind of 7th grade middle school St. Vincent bit, irrational numbers would be students that go to a totally different school, right? They're not part of the St. Vincent community, not part of the rational set. They're irrational for going someplace else. Okay. We didn't get a chance to warn you. I did not know that I was going to be visited today by the boss. Here's what has to happen when the boss comes in the classroom. Okay? Whenever I ask a question, everybody raises their hand. But here's the bit. You raise your right hand, that means you know the answer and you're comfortable with me calling on you. You raise your left hand, I will not call on you because you're only doing it to make me look good. Right? Can we work together on this? Okay? So whenever boss comes in the room, right hand, I know it. Call on me. I got you, Schultz. Okay? Left hand, I'll get you next time. Not this time, but next time. Okay? Good? Go team, go. Okay. I'm going to pause the video. Probably should have paused it for that, but oh well. I'm going to pause the video. I want you to work on the bottom row here. We've got, we're almost out of time. We'll make this homework. Next page. Sorry. There we go. The next page continues the homework. It says, what is a rational number that is not an integer? We'll do a couple of these together. What is a rational number that is not an integer? So what are you looking for that would make the number rational but not an integer? Melanie?
7.2.
Sure, an example, 7.2. Why is it rational? Because it's a decimal that ends. Why is it not an integer? Because it's a decimal. Okay? What is a whole number that is not rational? A whole number that is not rational.
2.
2 is rational
Oh.
because it's that positive non-decimal. Trick question, right? Trick question. Every whole number, I keep you on your toes. Every whole number is also rational. Remember? Every student in the 7th grade is also part of St. Vincent. If you look at the rectangle box thing, right? The whole number, the most specific set. Every whole number is also part of the rational number set. So some of these might be trick questions. Okay? Sorry. but gets you thinking about what those different categories are. Okay? Then the next section says determine whether the statement is always, sometimes, or never true. An integer is a whole number. Is that always true? Sometimes true? Never true. Who's feeling bold, brave, and believes in themselves and wants to answer this question? An integer is a whole number. Is that always true, sometimes true, or never true? Ava?
Sometimes.
Sometimes true. Very good. Yep. An integer is sometimes whole. If the integer is positive, it is also whole. If the integer is negative, then it's just an integer. Well, it's also rational, but it's not whole. A whole number is rational. Are whole numbers always rational? Are they sometimes rational or never rational? Layla? Always rational. Whole numbers are always rational. Okay? Then, the next section, you get to use a calculator, and you are to evaluate each radical, classify it as rational or irrational. What you're looking for is it a perfect square or not? Okay? Does anyone know what the root of 225 is? Quick math, anybody?
5.
Not 5. It's got a 5 in it. 15. Okay? If you calculate the root of 225, it is 15 exactly. Is that rational or irrational? 15. Rational or irrational? Rational, right? Positive, non-decimal. A number like the root of 83, though, you calculate that, and you're going to get something like 9.17238602, and it's going to go through the entire display of your calculator. It does that because it goes on forever. Okay? Perfect squares that work out evenly, rational. Non-perfect squares that give you a decimal, always irrational. Alright? You do use a calculator for that one. Finally! Gosh, I'm piling on day one. My goodness, you're not going to like me. You're all going to unsubscribe. You and your parents are gathered around the TV one night watching the Discovery Channel when suddenly you lose your satellite signal. Not being used to interacting socially, things are a bit awkward. But then, you get an idea for a game. Each of you will take turns saying a number from one of the categories listed above or below. Your category is rational numbers only. Your mom can only say numbers from the integers, and your dad can only say whole numbers. You just take turns saying numbers from your category. The question is, the winner is the person who can say numbers from their category the longest. Assuming that you're each familiar with the categories, your dad knows what wholes are, your mom knows what integers are, you know what rationals are, right? Who will win? Who will be able to say numbers from their category the longest, and why? Okay? So, like we talked about yesterday, homework is graded on completion, not accuracy. I do expect every question to be answered for you to get credit for doing the assignment. This is due tomorrow, okay? You've got the rest of class, 0 minutes to work on it, you're welcome. And then of course, tonight as well, okay? So, my outro, remember what it is? With gusto, that's how you math. Don't forget to like and subscribe.
Don't forget to like and subscribe.
We'll try it again. That's how you math.
Don't forget to like and subscribe.
Very